What I am going to do now, I am going to use formulas. The way I'm going to teach you how to integrate, it's going to be different from other YouTube videos because I believe that most students suffer a lot in integration because it is not proper structured, right? Now, what we are going to do, I am going to integrate, let's say integration using formulas. So the use of formulas, actually, it is the U sub. But I do not want you to dwell to the U sub. I do not want you to dwell in the U sub. I do not want you to do that. But what I want to know is that when integration, because when integrating, some of the problems do not require you to use the U sub. It's going to be too long. But what we actually need, we need to know, you need to know actually how it is done. Right. So let us look at the first one. You know that the integral of e to the power x dx, it is what? It is e to the power x plus c. You know that, right? What you also know is that when you derive e to the power ax, you are going to get y prime is a e to the power ax, right? You actually know that. Now, when I say integrate e to the power ax dx, when we derived, let me just get a black. When we derived, we actually multiplied by the exponent. When we integrate, we are going to divide by that constant. You understand? When we derive, we are actually going to divide by that constant that we integrated when we multiplied, that we multiplied it with when we derived. Do you understand that? So when we derive this, we multiply by the constant. When we integrate, we divide by the constant. So it's going to be the same principle for the sine of ax dx. Your integral of this is going to be negative 1 over a cos ax plus c, and integral of sine ax dx is equals to 1 over a cos ax plus c. These are the rules that are developed using the U sub. So when you see this particular thing in an exam, go straight to an answer. Do not try to use the U sub. Yes, indeed, the integration technique that is used here, it is the U sub, right? Let us look another one. Let us look at another one. An integral of cos ax dx. It is 1 over a sine ax plus c. And when we integrate cos ax dx, you're still going to get 1 over a sine ax plus c. Right. You actually know how to do this. Please, I'm begging you when you do this. Again, when we integrate 1 over x plus a, where a is a constant, let's put a b there, ab dx. This integral is going to be b ln x plus a plus c, right? When we integrate b over ax plus c dx, what we are going to have here, our integral, it is going to be b over a ln ax plus c. Now this c is for the general thing, right? We actually going to perform these calculations, right? These calculations, please be aware, because we are going to some integration techniques. You will need these basics. So let us look at an example. So an integral of 1 over 4 e to the power of 4x minus e to the power minus 4x plus cos 3x minus sine 1 over 7x dx. Here, there is no need of doing the u sub. There is no need. Just use the formulas here. What are your a's? Your a's are the 4, the 3, the 1 over 7. So your integral here, remember, I'm going to have 1 over 4 in bracket 1 over 4 e to the power 4x. Right. This 1 over 4 here that you see, it is this part. That part, it is this part here. Right. So if this part here, it is this part here. And then this 1 over 4, it's that part. Right. And then minus in bracket negative 1 over 4 e to the power minus 1 over 4. Plus, what is an integral of cos 3x? 1 over 3 sine 3x. Minus, what is an integral of of sine 1 over 7? 1 over 1 over 7 cos 1 over 7x plus c. And I'm pressing the calculator to simplify there and there. So here I'm going to have 1 over 16 e to the power 4x plus 1 over 4 e to the power minus 4x plus 1 over 3 sine 3x, and then minus 7 cos 1 over 7x plus c. So this is the use of formulas. You need to be able to use these formulas, guys. You need to be able to use these formulas. They need to be embedded in your brain. Make sure that since we are also going to do the Laplace transforms need one of these formulas here when you do the Laplace transforms theorems. So make sure that you understand some of these examples, and make sure you do examples. Put numbers where I did not put numbers. Put shines where I did not put shines. Right? Make sure you understand. Right? So let us look at another example. An integral of the square root of x minus, I'm also going to go to the square root, relax, minus sec squared negative 3x plus 1 over x minus 7 minus 8 over 7x minus 4 dx. Let us use the formulas. To integrate a square root of x, to integrate the square root of x, your square root of x must be written as x to the power 1 over 2, so that I can add the 1 and divide by 1. So it's going to be 2 over 2, which is going to be 3 over 2. So I'm going to have x to the power 1 over 2 plus 1 divided by 1 over 2 plus 1 minus, what is an integral of that? It's minus 1 over negative 3. What is an integral of 6 squared? It's going to be the tangent of negative 3x, like that. Plus, what is an integral of 1 over x minus 7? This is the formula that we use. Since our b here, it is a 1, so it's going to be ln x minus 7, right? Minus, how do we integrate negative 8 over 7x minus 4? Now, when we have b and a, what we need to do, we need to say it's negative 8 over 7 in bracket ln 7x minus 4 plus c. So we can simplify this to have, I'm going to have 3 over 2, which is going to be 2 over 3x to the power 3 over 2 plus 1 over 3 tangent of negative 3x plus ln x minus 7 minus 8 over 7 ln 7x minus 4 plus c. So we can leave your answer there. You can also leave your answer here, but because we have to simplify some stuff, so you need to simplify first, right? So I think you understand here. You can really pause, try to understand, because we're here in the video. Now, what I'm interested in, it is by completing the square. By completing the square. For now, we are not going to do the hard ones. We are not going to do those ones. But we are actually going to do the small ones. I'm still looking for integration by completing a square. There are things that I want you to understand and some formulas that you actually need to know. These are the formulas that when you integrate 1 over the square root of a squared minus x squared dx, you are going to get arc sine of x over a plus c. When you integrate dx over x square root x squared minus a squared, you're actually going to get 1 over a arc sec of absolute value of x over a plus c. And then when you integrate 1 over x squared plus a squared dx, we're actually going to get 1 over a arctangent of x over a plus c. It's going to be quite different if we say the integral of a over bx squared plus k squared dx. Our integral here is going to be a over b times 1 over k arctangent of x over, sorry, it's not going to be something like that. It's going to be 1 over the square root of k squared over b arctangent of x over the square root of k squared over b plus c. So this is the formula that you use if you have this case. So we use these formulas when we complete a square, but what I'm actually going to do for now, I'm just going to play with these formulas. Especially, I'm going to play with arctan. I'm just going to play with arctan. So when we integrate 1 over x square root x squared minus 3 dx, your answer to this thing is same as that. I'm going to have 1 over root 3 arcsec of the absolute value of x over the square root of 3 plus c. That is your answer, really. Right? When we integrate 1 over 4 minus x squared, our answer here dx, it's going to be sine, which is arcsine of x over 2 plus c. Now, you see that if you have an a square here, you have an a, which means you're actually going to take the square root of that number. And also, when we take the integral of 1 over x squared plus 4 dx, we follow this rule here. We are going to have 1 over 2 arctangent of x over 2 plus c, right? We're just following these formulas. And the last one, which is the substitution, when we have 7 over 8x squared plus 1 dx. Our answer here is going to be 7 over 8 in bracket 1 over the square root of 8 of 1 over 8 arctangent of x over the square root of 1 over 8 plus c. So that is your answer, right? That is your answer. We are just applying these formulas. And then, in the next video, if I'm not mistaken, we are going to talk about these substitutions. Please do not be scared whatever you're going to see, but I'm just going to start with the easy ones and then proceed to the hard ones. Thank you.